In this video, we're going to learn to graph sine and cosine functions. And in the next video, we're going to learn how to graph the tangent function. So with sine, remember, usually we have, 0 and then 90 degrees, and then 180 degrees, and then 270, and then 360. But instead of doing that, let's use radians instead. So this is pi over 2, because that's 90 degrees. Then we have pi. Then we have 3 pi over 2, which is the same thing as 270. And then finally, we have 2 pi. So remember that pi hovers around -1 and 1. And all we have to do is graph. So if you can't remember what sine of theta looks like, sorry, I might have just said that pi hovers around -1 and 1. I meant sine of theta hovers around -1 and 1. So let's go ahead and draw this. We know that this is 0, 1, 0, -1 from the unit circle. So at 0 degrees, sine theta looks like this. At 90 degrees, sine theta is right here. At 180 degrees, we have this. And then 270 degrees, we have -1. And then finally, back to 360 degrees, here we go. And so the sine graph looks like this. There you go. One thing to note here is this is not a semicircle. It might have seemed like it might look like it's a semicircle because of the way I drew it, but it's not a semicircle. So don't think that this over here is just one big circle. No, it's more of an elongated shape. Now that we drew sine, let's go ahead and draw cosine. So cosine theta, we draw the unit circle here. Once again, it hovers between -1 and 1, but you go from 1, 0, -1, 0. Let's see, pi over 2. Ooh, switch these around actually. Three pi over 2 and 2 pi. At 0 degrees, actually let me draw 1 and -1. At 0 degrees, we start from the very top. 90 degrees, we go to 0. 180 degrees, we have -1. 270 degrees, we're back at 0. And then if we end up all the way at 360 degrees, we're back at 2 pi. So it looks something like this. We have half of that little like oval looking shape. So remember, it's not a circle, but we have half of that, half of this at the end, and a full half like oval shape here at the bottom. It's important for you to know this because we're going to combine what we learned with the transformation stuff with trigonometry. Right? For the phase shift and vertical displacement, actually, let's just do an example over here. Okay, I'm going to ignore amplitude and period, and I'm going to ignore amplitude and period. Phase shift and vertical displacement just really means how much is it moving to the left or right, and up and down. So we know that our original function is cosine of theta. Over here we have -3 cosine. Remember that we have to factor out the 3 over 2. So I'm going to take out the 3 over 2. Then we have x plus, and if you can't see this right away, pi over 2 divided by 3 over 2 is pi over 2 times 2 over 3, which is pi over 3. So plus pi over 3, close the bracket, and plus 1. We're going to keep going over here because we don't like to write the b value on the left. We want to write it on the bottom. So this is actually -3 times cosine of x plus pi over 3 over 2 over 3 plus 1. And so I'm not going to draw what this graph looks like, just because the purpose of this lesson isn't to actually draw it again. You've learned it already in transformations. But I want to go through the step-by-step of how it would look like if you drew it. First, we have a vertical reflection, or a reflection along the x-axis. Then we have a vertical stretch by 3, okay, vertical expansion by 3. Then we have a horizontal compression by 2/3. We're moving to the left by pi over 3, and then we are moving up by 1. You can do this as an exercise if you want, but because the video is going to get a bit too long if I demonstrate this, I'm just going to leave it as an exercise for you. If we look at this over here, well, it's already nicely placed for us, so no need to simplify. We have a vertical expansion by 2, and, oh, actually I lied, okay? We do want to change it a little bit. 2 sine times sine x minus 2 over 6 over pi minus 3. 6 over pi, well, pi is 3.14, so 6 divided by 3.14 is just under 2, so maybe like 1.8 or something like that. We have a vertical expansion by 2, horizontal expansion by 6 over 2 pi, or around like 1.8, 1.9. You're moving to the right by 2, and then you're moving down by 3. So we relate this back to the transformations unit, and all we have to do is move it up, down, left, right, do some sort of reflection, and then maybe stretching, expanding, or shrinking, compressing.